Okay. Hi, my name is Vlad Nedelcu. I'm a PhD student at the University of Edinburgh Center for Language Evolution, and I'll be presenting joint work with my supervisor, Kenny Smith. So, in our daily lives, we get to interact with a lot of very different people. These people not only differ in what they know about us, about the world and the people around them, but they also use different dialects and even different languages. Now, all these have important consequences for how we interact, because even if we're pursuing the same communicative need, like say giving directions to the same place, we'll still need to adapt our utterances so that our communication partner can understand us, or in other words, so that we meet their communicative needs. So to illustrate this point, suppose you are a native of the city of Edinburgh. So one day you are having a stroll through the historic Georgian New Town when someone stops you to ask for directions towards a certain pub. Now, if that person is your best friend, you might not even need to give any directions at all. Perhaps you've already been there with them and they just forgot about the place. If it's a local, then you're probably safe using the names of public buildings or recognizable streets for your directions. And if it's a tourist, then it's probably best to stick to very well-known landmarks like Edinburgh Castle or otherwise buildings that are easily recognizable along the way. So in all these cases, your surroundings as a speaker stay the same, but the directions still differ in complexity. And that's because there's more to context than just the immediate environment. Context is also about the knowledge that you share with your partner. And in this example that I gave, the shared knowledge decreases with each subsequent partner, so you'll have to compensate with a more complex utterance. But it has been argued that if the people around us differ reliably across communities, then this phenomena can affect not just how we use language, but actual structural features of language. And particularly, we were interested in looking at how this phenomena can shape the level of compositionality of a language. And just to avoid any confusion, by compositionality, we mean the property that utterances are composed of parts, with the meaning of the whole being a function of the meaning of these parts and the way in which they are combined. So Ray and Grace explored this to some extent in this Lingua paper. Particularly, they defined two types of languages, inward-facing, which is between partners that share a lot of common ground, so partners of the same group, and outward-facing, which is with partners that share less common ground between themselves, so members of different groups. And they argue that a language with mainly inward-facing usage will have a lot of common ground to exploit, and that will leave outsiders out. So the language will be only spoken by this tightly knit community, and the language will evolve to adapt to this community's needs, and it will be more context dependent and have more irregularities. Whereas the language that is, has a lot more outward-facing usage will be easier to acquire for adults, so it won't be able to use that much common ground, and that means that it will evolve to be more transparent, more compositional, and more context independent. So there have been some experimental studies that show how context can shape the conventions that evolve between two partners. So most interestingly, Winters and colleagues look at compositionality, and Hawkins and colleagues look at purely lexical conventions. But the problem with both of these works is that they only look at dyads, so only interactions between two partners, and only single generations of language users, which means that they cannot really tell us much about the Ray and Grace theory. So our model will use these two experiments as the starting point, but it will add the missing puzzle pieces as well. So both of these studies, as well as our model, make use of asymmetric reference games. In the simplest form, these games have two participants or two agents. There's a sender and a receiver. So the receiver is presented with a context of reference, and the purpose of the game is for the receiver to identify one of these reference M being known only by the speaker a priori, and the receiver will have to identify M based on the sender's utterance. And this is for one round of communication, but these games typically take place over multiple rounds. And in our case, in each separate round, there is a different context for the receiver. So we manipulate two aspects of the context. First, whether or not the sender shares access to the context of the receiver. And we also manipulate the actual context type of the receiver. So this is the first out of 4 situations. Here we see that the sender and the receiver share access to the full context, so they both see the same thing. And we see that reference always differ in just color. So here in each square we see the available contextual information from the perspective of the sender and of the receiver. And here we see that the communicative need of the receiver is just to have the color communicated. If we have a one feature different context type but an unshared context, then the communicative need of the receiver stays the same because the reference still differ in color. But this time the speaker only sees the correct referent in isolation. So that means that it will have to infer the communicative need of the receiver throughout the communication game. And when we have a mixed setup, we will have a context where sometimes reference differ in shape and other times they differ in color. So the communicative need of the receiver is sometimes to have the shape communicated and other times the color on a round by round basis. Otherwise, we have the same distinction between a shared and an unshared context. So we represent languages as sets that contain pairs of signals and their associated meanings. We have 4 meanings, 4 signals. Both signals and meanings are structured. So that allows us to split languages into multiple classes. We have degenerate languages, which use a single signal for all meanings. One feature languages, which only enable distinctions to be made based on one feature. Here it's just shape. Compositional languages, which have consistent mappings from each feature to a separate signal units. Hybrid languages, which mix the above two. And finally, holistic languages, which have idiosyncratic mappings from each signal to a separate meaning. So our model consists of multiple mechanisms. We have language learning, which is implemented as a process of Bayesian inference. We have communication, which is modeled as pragmatic reasoning following the Rational Speech Act framework. And transmission from one generation to the next, which is modeled following the iterated learning framework. So the agents in one generation observe the behavior of the agent from the previous generation. So in the simple case where a sender interacts with just one partner, so just as in the 2 experiments that I talked about earlier, the sender will only track 2 abstractions. So it will track the context type of the receiver, of its partner, in case it doesn't know the context. So this is for an unshared context. And it will also track the language, a distribution over possible languages that the partner could be using. So we have 2 mechanisms involved here. We have in blue the background expectation that the sender brings to the interaction. And in green we have the evidence of how the partner uses language. So we have these simple communities of just 2 agents, and we want to see what the language would evolve over time. So we run simulations of 200 generations, and we run a bunch of these chains in parallel, and we look at the final average posterior distribution over the language types that I talked about for all the agents. And let's first look at these 2 bars, which have the conditions where the sender and the receiver share the context. So this is for a shared context. So when the receiver has a one feature different context type, so reference always differ just in shape, we see that mostly one feature languages dominate the posterior, which makes sense because these are the simplest communicatively functional here. Whereas when the receiver has a mixed context type, we'll see more compositional languages evolve. So either fully compositional or hybrid. And again, that makes sense because encoding just one feature will no longer be sufficient. And with an unshared context, we see the exact same effect if we compare the results from the one feature different context type and mixed context type conditions. So this nicely replicates the results of Winters and colleagues from the paper that I showed earlier. And particularly, it tells us that there is less compositionality emerging when there is only one feature in the agent's common ground than when there is no feature in the agent's common ground and the objects differ in both features. But now, more interestingly, let's revise our abstractions to support interactions with multiple partners instead of just one. So since these partners can have different communicative needs, the sender has to track a different representation of context type for each partner. And it will also track a distribution over possible context types across the community and a community-wide distribution over possible languages. So we see here that we have abstractions at two distinct levels instead of just one level when we had one partner. So we also need to add one more mechanism because of that, a mechanism that captures how evidence from one partner's language generalizes to others. So we can watch these three mechanisms in action by looking at how sender uncertainty over context type develops over a sender interacting with three receivers. So first, all priors and hyperpriors are set as uninformative, so the sender picks a context type at chance. But as it starts observing its partner's behavior, it will gradually infer the correct context type for that partner. And after it stops interacting with this partner, it will update its hyperprior, and before it starts interacting with the second partner, it will have a weak bias towards the context type of the first partner. And that bias only gets stronger and stronger if all subsequent partners have the same context type. But if, let's say, the second partner has a different context type than the first and the third one, then this bias will actually set the sender back, right? Because in this case, for the first couple of rounds of communication, the sender will think that it's more likely that the receiver has the context type of the first receiver when that is not the case. And it will take a little bit of time for the sender to adapt to that and to overwrite its bias. And as well, by the time we get to the third partner, there won't really be any particular bias for just one context type. Sorry. So let's again look at some simulations. So the four bars here are from the one partner results. I'll keep this in the background because I'll need them for later. But we'll focus at the last three bars now, which look at the results for the multi-partner model. So when we have one sender interacting with three receivers. So if we look at these bars where all receivers have the same communicative needs, so either they need just the color or they need both the color and the shape, we get the same results that we had previously. So we see that one feature different contexts. With receivers with one feature different context types, we see more one feature languages. But more interestingly, we can look at the three simulations where receivers always have contexts that differ in just color. So this is two results from previously and one from the multi-partner model. So when the sender only has uncertainty about the language of its partner, so if they share context, we see these results here. If access to the context isn't shared, then we also have the sender also has uncertainty about the context type of its partner. And if there are multiple partners instead of just one, then there's uncertainty about the context type of each individual partner. And we see that as the level of uncertainty increases, the proportion of one feature languages actually decreases, and the proportion of more compositional languages increases, and that's because they will prefer a language that is more robust to uncertainty. And finally, we can look at the cases in which a sender interacts with three receivers that all have one feature different context types. But for this bar, we have all three receivers have color different contexts, while for this one, we have two receivers with color different contexts and one with shape different contexts. And we see that there will be more compositionality when we have this heterogeneity. And then that's because they will want to have a language that maximizes the communicative success across all interactions. So to conclude, we've built an iterated hierarchical Bayesian model, and we've seen that the compositionality that evolves in a community depends on three factors: on the communicative needs of its language users, on the degree of center uncertainty over these needs, and on the amount of heterogeneity in a community's communicative needs. So we're now extending our predictions for more complex social groups and are aiming to test them with our own set of experiments. Thank you.